Hello all, welcome to part 11 of the Wireless LAN Security Mega Primer. This video is aptly called Alpha Card Kung Fu. So the reason I've called it so is because in this video we will take the Alpha Card and look at some advanced functionality to help us with our penetration testing. So let's start with a quick recap of what we had learnt in an earlier chapter, which was about operating frequencies, bands, and ranges, and all of that. I think which was in chapter 2 or video 2. So, there we had actually said that the exact frequency range in which a card can operate in a given country is dictated by the various regulatory policies. As an example, the FCC in the US is responsible for the regulatory policies there as far as the 802.11 spectrum is concerned. So we can actually see that from channel 1 to channel 11 is allowed in the US, while in Japan channel 1 to 14 seems to be allowed, right? So a lot of interesting stuff. Now what we will do is we'll try and understand how the alpha card decides on various country-based frequencies which it needs to use. So let me go back to my backtrack instance, and currently if you notice I have not connected my alpha card. Let me open up two terminals, and in this terminal I am going to monitor the kernel messages. Right, let's kind of go back here, and now what we're going to do is let's plug in our alpha card and we'll see something very interesting. So I've plugged it in and a lot of interesting output seems to be coming. So if you notice, this actually says, well, USB blah blah blah, and after that it actually says something called calling CRDA to update world regulatory domain. World regulatory domain updated, and then we have a little ASCII table which says start frequency, end frequency, and then from there on you have max antenna gain and max EIRP. Let's try and understand a couple of these things. So the start frequency and end frequency actually talks about the different frequency ranges in the bands. And if you kind of remember, 2.482, if we go back to our little chart here, is actually just before channel 14. So here is something interesting. Our card has automatically set itself up to operate in various frequency ranges and in various power ranges. So let's understand the power part as well. Let's go back here and now go to the next slide. So you've heard a lot about DBM and things like that when you may have purchased this card, and you may be curious about what it is. Some of you may already be aware, but let's go through this slide to get on the same page. So transmit power, when we talk about RF devices and antennas and all of that, typically is measured in a quantity called dBm, which is actually a logarithmic scale. Now I won't get into the details of how you calculate dBm and all of that from a given antenna or a given RF device, because that is in the domain of microwaves and antenna theory. However, what is important for us to notice, if you remember, we bought this alpha card and said it can transmit at a maximum of 1 watt. If you look at this table, which is a conversion of dBm and watt, 1 watt actually stands for 30 dBm, right? And 27 dBm actually stands for 500 milliwatt. Okay, awesome. Now, what is EIRP? If you remember, here we did not see like the maximum transmit power. What we are seeing is the EIRP, max EIRP. So what this actually means is the following. EIRP actually stands for the effective isotropic radiated power, and the whole idea is to calculate the effective radiation power for a given RF device along with the antenna and the cable. What do I mean by that? Well, here is an RF device. This is the actual device. Here is the antenna. We may also have had a very long cable going from this device, and maybe we could have mounted an antenna somewhere on our terrace or somewhere else and done a lot of other interesting things. So if you want to calculate the effective isotropic radiated power of this set, you will take the transmitter power in dBm, take the antenna gain in dBi, add both of them up, and the reason it would be additive is the antenna is actually enhancing the overall signal coverage and even direction at times of the transmitter. That is why we add both of them, because they aid each other. Then we subtract the cable loss. Why? Because when the signal travels from the transmitter till the antenna, the cable through which it is traveling attenuates the signal, and hence we need to subtract that part. Once we calculate this, this is what is the EIRP. So when you say max EIRP allowed, this actually means that this is the max EIRP or the max radiated power this setup is allowed to send out. Now 2000 MBM is actually 20 dBm, right? So now what does all of this actually mean? Well, let me kind of come back here and let's check if our alpha card is up. It isn't, so let's bring our card up. Wait for a moment. So while this is happening, hope you guys are enjoying this video series. I know I'm going very deep, very elaborate, but I personally feel this is how any topic should be taught. Not in half an hour, but should be taught in so much depth as if I'm in a class. Okay, so the card seems to be up and we have WLAN 0. So let's set the card to channel 1. Card is in channel 1. Let's do an IW config. And if you notice, the frequency is 2.412 gigahertz and the card is transmitting at a power of 20 dBm, which if you notice was the maximum power which is currently allowed based on the regulatory domain setting. So let's do the following. If you remember, the alpha card was 1 watt, which is 30 dBm. So let's change the transmit power. You can do that using the IW config utility, WLAN 0 TX power, and we can simply write 30. When we just use the numeric value, the utility considers the metric to be dBm. If you notice, it is not allowing us to set the maximum power. Similarly, let's try various channels. Channel 11 works, channel 12 works, 13 works, 14 works. So we are able to move across all channels as described by this different frequency range which is being allowed to us, right? It's going all the way through channel 11, 12, 13, 14. However, we are not able to set the power. Now what is the solution? Now the first thing you need to understand is you will have to use the card based on the regulatory domain you're in. So let's assume I am in the US, then I will have to honor the regulatory domain requirements created by the FCC. Now going by that, I will need to apply all of that on my card. How do I do that? Well, very simply, Linux already has all the requirements stored in a little file called db.txt, which we actually use in a very different way along with the wireless subsystem in the Linux kernel to go ahead and switch our card to the appropriate regulatory domain. Now let's assume the country we are in is in the US, which would actually mean this is what would dictate what we do, right? So let me now change my country by using the IW command, and this is a very interesting command. I would encourage you to have a look at all the things this command actually allows. right? And this can even be used as a replacement for IW config. And actually moving forward, I think that is what is going to happen. Before that, let's actually just quickly bring our card back to channel 1. And it would be a good idea to actually even bring our card down while we are changing all these settings, right? So we'd use IW, and then after that there's a very simple command here called regset followed by the ISO IEC 3166-1 code for the country. So the country code is the for the United States is US. So we can actually write IW, and after that you actually have the rest, which is regulatory domain set US. Now when we hit this, we'll actually like to see what's happening here in these messages. This would be interesting to see. Let's actually clear the screen up a little bit. Here we go. And if you notice, it says regulatory domain currently changed to the US, where now we are allowed a maximum of 27 dBm. Great news, but the frequency has been chopped down a little bit. So let's actually use the ifconfig command to bring up the device once again. Now we could try changing the power to a maximum of 27 dBm. Could maybe use the channel 1, and if you look at the values, you would notice the power has been set to 27 dBm. But if we try once again to change the value to the maximum of 30 dBm, which would be 1 watt, you would notice that it does not allow us. Also, when we try to go beyond channel 11, which is what I think is the last allowed channel, if you cannot go back in the slides in the US, right? It once again does not work, right? Channel 12 doesn't work. Channel 13 also doesn't work. So this is where we're kind of hitting an issue. Depending on the country we are in, we are supposed to go ahead and follow this, but at times maybe you are roaming, maybe you're in a different country doing a penetration test. So what do? And this is where what we would ideally want is a lot of flexibility in both the channels as well as the transmit power. Now, there are ways by which you can tweak this, right from probably modification of the wireless kernel subsystem, or even the regulatory file, and try out various different things. But the easiest hack is actually to find a country code which allows you a lot of flexibility, right? So kind of coming back to the presentation, what we need is actually to be able to find a country code which is going to help and support the channel and max transmit power. Now it is important to note that this is all for educational purpose, and depending on your country, it may be illegal to transmit on some channels and some powers, right? For example, in the US in FCC, I think channel 12, 13, 14 are not really allowed. Anyway, so this is where we can quickly locate two interesting countries in that large file which we saw. One is Bolivia and the other is Belize. I hope I'm pronouncing that correctly. So if you kind of go here, you will notice that Bolivia actually has a huge range of allowed frequencies and up to a maximum of 30 dBm, which is quite huge, right? And BZ or Belize also offers the exact same range. So let's now go back here, bring down our card, and now once again change our regulatory domain to BO. If we look at the different kernel messages, you would actually find that the change has happened. And now if we kind of bring up the card, This always takes time. We can set the channel, let's say WLAN 0, channel 12, and also we can set the TX power to 30 dBm, which should be 1 watt, right? Interesting. And with this, it is possible to set the alpha card to a higher power and also play around with the frequencies, right? So I guess this is what I had in mind for this video. The whole idea is that the alpha card is powerful. However, because of the regulatory compliances, you might not always be able to set it to certain frequencies which you may want to monitor or transmit data on. It is important to note that you are governed by the laws of the country where you are in. So please take care of that before doing any transmission on any of those channels. At the very same time, if you are probably moving around or going to another country, it is advisable to change your alpha card to match the country's spectrum guidelines, which are already being fed into the Linux kernel using that huge database file which we just saw. So that's all for this video. Hope you enjoyed it. I guess a lot of you had questions about the card power, etc. Hope it is answered right now. I think Black Marketeer had asked that question. Hope it's answered. Looking forward to seeing you guys in the next video, and please do leave your comments behind. I really loved reading them, and that is what encourages me to create more videos. Thank you and good night.